cards. That's what confidence feels like.
I love the new WW program because it's tailored to you. Take the personal assessment and get matched with a proven weight loss plan. Find out which customized plan can make losing weight easier for you. Like WW, eat rapidly, live lose the weight.
August the 13th was a great coup, but now I'm renewed. In this state of ours, it seems impossible to avoid cost.
The body count isn't what drives us. Holy Father, I have to tell you something.
You called me. I came back. Now tell me why.
Nothing about Harley.
That's where my life stands for something I didn't do. I will find a system to screw me over. Maya, new series, Tuesday, February 11th, on CTV.
Well, he seems to have gotten rid of her starter. Perhaps. Yeah, what's something?
I'm on.
Did he have facial fractures we were able to fix? Then we discovered he had fluid leaking from his brain. But after Carrasco was able to get in there and patch up the leak.
Welcome, people. Questions?
Dr. Tommy is...
Tommy Karasik.
Oh. Yeah. Yes.
Well, he's our angel. When he offered Blake the job to come out here, he said no. He didn't want to leave me behind. It's just been the two of us since his parents died. But Dr. Tommy wanted him badly enough. He paid for me to move to Seattle. I knew he must be beating himself up that this happened. I told him that it was a freak accident. But you know how emotional he is.
MC.
Yeah, super.
It could be both. The multiple choice are based on a variety of factors.
There is a slow recovery. His strength should come out in a day or two. As long as everything goes well. Right.
Just to check, did you hear?
No, not at all.
Can people hear me?
Can I
Okay,
go
they can
in
hear.
alone? Absolutely.
I don't know what the multiple choice will be based on. I have to make them still. You can't assume that there will or won't be a change in state. You have to look at the temperature change. So let's say I'm calculating a delta T, and I calculate that a temperature change is 76 degrees Celsius. And this is for water. But if my initial temperature change was 40, if I add 76 degrees to that, that'll take me past its boiling point. So that's what tells me I go through a state change. And so I'd have to back up and do it. Yes, you need to find total enthalpy. Edward, you have to recognize the three different ways that we talked about for reporting enthalpy change. What are the questions, Nupur? Okay, so I have questions for sheets. So just give me a second to get the sheets.
Can I go in there? Absolutely.
Yeah, of course, yeah. That's the assembly. That must have been a great catch. I'm really grateful. Truly. Yeah, we got this.
Yes, you subtract for if it's a cooling curve. Sublimation would be for a cooling curve as well. So you have to look at what's going on. Okay. Okay, you just got to give me 2 seconds to get the sheets. Delta H fusion is for its melting point or freezing point. Delta H vaporization is for its boiling point or condensation point. Lots of questions as you want me to. Yes, you always go step by step. Okay, on a cooling curve, I have to look at how much energy is required to cool each section and is going to go from my surroundings into my system. So if I have a total energy change, I have my system that has gone through an energy change of, say, 2,400 kilojoules. Is a question of how much energy change is associated. So if this change right here requires a change of 1,000 kilojoules, then I have 1,400 left. And so you're always subtracting. Okay, so I start off with 2,000. If it takes 1,000 kilojoules to condense during that region, I'm subtracting. Yes, it's okay if you have empty space in your cue card.
Yay, that was cute.
Okay. No, it's okay. I got the sheet. So the first question was 14 and 15 from the textbook enthalpy. So this one, sunny days, heat the floor. Okay, so 14, which is this question. Okay. A couple of things. Let's deal with these questions first, and then I'll deal with the cooling curve. Okay. So somebody asked about 14. What I'm going to say about 14 is you're being asked for the energy change. This is just surrounding. There's no system. And so you're looking at the energy change in your surrounding. And so your Q is equal to N times delta H fusion. And so you know your mass, you know your enthalpy change, you know your equation, so you can get your molar mass and get your change. Okay. For question number 10 on this sheet. They're just naming different types. So this is molar enthalpy of fusion, vaporization, molar enthalpy of condensation, molar enthalpy of solubility, molar enthalpy of combustion, molar enthalpy of neutralization. Okay, number 12. It's an exothermic reaction. So I add water, acid to water so that I have surrounding to absorb the heat. If I don't have enough surrounding to absorb the heat, then I could vaporize the little bit of surrounding that's there. And so for safety's sake, we have lots of surrounding so that it experiences a small temperature change. Okay. Okay, number 15. So this is that's your system, that's your surrounding, and that's your volume of your surrounding. So whatever your molar mass is, right? And then you have your system. Because your volume is 200 milliliters, your mass is 0.25 grams. And you can get your delta T, which is 7.1 degrees Celsius. And then you can just finish solving it. No, don't worry about 16. Okay. So these were the questions that people were asking about the enthalpy worksheet. For Ian, it doesn't matter if you go kilojoules per kilogram or joules per gram. Now, let's talk about the one that is now confusing a bunch of people. Okay, so I have a system, and the question is, if I have, what would be my final temperature? Because my system is endothermic. So my delta H is equal to positive Q. And so we have our mass, we have our molar mass, we have our delta H reaction. And let's say we calculate a delta H that's 1200 kilojoules. Okay, so that's how much energy has to go into my system. Okay, if I look at my surrounding, right, I have my mass, I have my initial temperature, I have my specific heat capacities. And let's say that I'm going to start off with it at 100 degrees Celsius. So my first question is, how much energy, and let's say it's 1 kilogram, just for making the math easy. Okay. So how much energy is required to cool it and to freeze all of it? Well, in this case, Q is equal to my moles times my molar enthalpy of vaporization. Okay. And so let's say, I'm not going to do the calculations. Let's say this works out to 700 kilojoules. 700 kilojoules came out of my system into my surrounding. Well, this changed state. So that means that I still have 500 kilojoules that has to come out of my surrounding into my system. So now the question is, so now I can cool it. And so in this case, I do Q is equal to MC delta T. And so I do my calculations and I get a delta T, let's say that's 67 degrees Celsius. Then in this case, what would happen is that my final temperature, T final, would be my starting temperature, which is 100 degrees Celsius minus the 67. So therefore, my final temperature in this case would be 33 degrees Celsius. So I'm subtracting because it's a cooling curve. Whereas if I have a heating curve and I have same thing, my delta H, but now because it's an exothermic for my system, my delta H is going to be negative 1200 kilojoules. So now I'm going to have to calculate my Qs for each of my regions. And so let's say it's at 0 degrees Celsius. I'd have to calculate my Q to melt. And so let's say, again, this is 1,000 kilojoules. So again, that means that my system gave into my surroundings 1,200. I used 1,000 of it. That means I only have 200 kilojoules to heat it left. Okay, so it's a subtraction, but you have to think about what you're doing. And this is why we said our Q is always equal, because it's equal to plus or minus delta H is equal to that, and we interpret, we always are treating our temperature changes as a positive value, and we interpret the direction that we go. Okay. Now, what does the formula for enthalpy change in fusion work? No, it works exactly the same way. Whether I have to add 50 kilojoules to melt a certain mass of water or cool, it gets me into the same thing. Okay. Okay, so the heating for hydrogen peroxide. So decomposition of liquid hydrogen peroxide. This is my overall reaction. And so then we would take our individual reactions. I'm not going to write the states unless they're not gas. Okay, so again, first thing we do, we look for things that we need in our overall reaction. Okay. And then we look to see, is it on the correct size? So we determine our multipliers and with the correct coefficient. So this one would be times 1, this would be times 1/2, and this would be times 1. And then we combine the equations. Then we combine our equations, or rewrite them. Okay. And again, I'm going to circle the things I want to keep. Then if I take this equation and I flip it, it will allow me to cancel that. And then I might be able to combine other equations as well. But I would have to go through and add them. Okay. You can use fractions at all times because we're in grade 12, so we assume. Okay. So many people have asked me about the potential energy diagrams. You need to recognize whether it's an endothermic or exothermic potential energy diagram, and that is it right now. You don't need to draw them or anything. You will draw them in the next unit. Okay. Now, I had somebody ask a question about one of the multi-step questions way back when. Number 2. Okay. So, multi-step question number 2. Combustion of phosphorus chloride produces phosphorus POCl3. Temperature rising for the surroundings. Using this information, determine molar enthalpy. Okay, so remember your steps. Oh, you want number 4, not number 3? Well, somebody asked for 2, so I'm going to go over how you do it. I'm not going to solve everything because the solution is posted. And then I'll go over number 4, how you would solve it as well. But as we said, first thing you need is your equation. Okay. So our first step is we need our balanced equation. And then we write down our standard piece of formation. This value, I'm sure, is in the table. That is 0. I'm just looking up the value for PCl3. Okay. We know that value. And then we can look at what we know about our system. We know our mass that we used. We can get our molar mass. We don't know our standard enthalpy of combustion for it. We know our surroundings is water because it said a heated water. We know the mass of water that was used. We know our specific heat capacity. We're told our temperature change. We know that it's an exothermic because the temperature of the surrounding goes up. So delta H is equal to negative Q. So we know Q is MC delta T. And then, so once we have that, so we can solve for this. It's a straightforward calculation. And then we can solve for our molar enthalpy of combustion, because it'll be equal to negative Q times the molar mass of PCl3 divided by the mass PCl3 that we used. Okay, so now I have a molar enthalpy of combustion. I can almost use it up here, but I have to remember for my balanced chemical equation, I have to calculate enthalpy change from a balanced equation using the coefficient in a balanced equation. So there'd be a 1, I get that value. So now I know my enthalpy change for my reaction. And then I can then determine the standard enthalpy of formation for my unknown. Okay, so look at the answers, but that's how, remember, it's process. Okay, so number 4, I'll leave it there for a second so you can see it. Number 4 that some of you are saying that you have problems with is done the same way. So C7H8. So use manufactured stuff. Okay, so it's allowed to undergo combustion. We'll say that. Okay. It results. Oh, so we're told information about our system. It causes a mass of 1.5 kilograms to have a temperature change of 10.14 degrees Celsius. And we're told that we used 1.5 grams of toluene. I will tell you on the test whether it's liquid or gas for the water. Okay. It's not told. Oh, here in a question, we're told it's liquid. So sorry. Just like on the test, I'll tell you. Okay. So if we look at the question, it tells you right there, H2O liquid. Okay. We can get our molar mass of our toluene. So it'd be 7 times 12, 70, 84, 92. Okay. Again, it's exothermic because the temperature of my surrounding went up. Okay. So we can calculate. We can calculate a enthalpy change for my system, or sorry, surroundings. I'm just getting a calculator. I might have to pause the live stream while I go beat my child. Okay, so I know the energy change of my surroundings. It was a mistake, energy. Okay, and then I can determine my molar enthalpy of combustion, because it's going to be delta H times the molar mass divided by my mass. So 63.6. Okay, so now I know my enthalpy change. I don't know, Hadassah, I might ask you to draw the graph. And then I'm going to say for my balanced chemical equation, again, I use a coefficient there. Okay. So I'm looking for that value. I know that's 0. I can look up that value. I can look up that value. Okay. So now that I know my enthalpy change, okay, and then I can do, now I can just substitute into there. And so it'd be 7 moles of CO2 times negative 395. This is negative 3909.5 plus. Okay, and then we just isolate for x, and then we get over with whatever the value is. I think works out to that. I don't know. I might have done the math wrong. Okay. As I told you in class, you're going to have a multi-step question on your test. So just so you know. Okay. Okay, so Vissalini asked for question 5 and 6 from the standard LPO formation page. Use standard formation. Okay. So 5 tells us NH3. So we can look up the values. That's not true, Suhangi. She reached her question quota, that's all. So we looked up our enthalpy changes. So question 1 says determine the enthalpy change for the reaction. I'm just going to quickly solve it. 1 mole times. Remember, you have to show all of your work. I'm just quickly doing this just to move things along. Okay, so we get an enthalpy change of negative 136.6. So this was question A. Okay. Question B says that asks for the potential energy diagram. So it's an exothermic reaction. So we have our reactants. Okay, our products have less energy because we know that it gave off energy. We label our enthalpy change. Okay, and then question C, calculate the heat that would be absorbed by 50 tons. That's just your system. You're given your mass, your molar mass, and we can get a delta H reaction by taking our enthalpy change from above and dividing by N, and that gives us this value. Okay, so that's for 5. I wouldn't worry about 6. Okay. Is the Super Bowl any good? I didn't watch it. I'm getting the Hess's Law worksheet. I don't have it, so I'm printing it so I can do examples. The only good part of the Super Bowl is the commercials and the halftime show. Okay, so Nupur is trying for number 9. For the following, calculate. So this is question number 9. So we have our equations. So now I'm going to look for what I need for each of them for my target equation. Okay. And then I'm going to determine my multipliers for each of them. Hey, happy birthday, Gadget. I'm live streaming for your birthday. That's your birthday present. So for the first reaction, I would multiply by 1/2. The second reaction, I'd multiply it by 1. So I'm just going to rewrite them so that I can see what I have with my multipliers. 2HCl gas plus O2 gas. Actually, sorry, equation number 2 has to be multiplied by 2. Okay, and I'm still going to circle what I need for my target equation. Okay, and then I have things I can't cancel out. So if I multiply my third equation by -1, it will flip it. And then that will allow me to cancel out things that I don't want. And then I can just add them together. Yes. So speaking of period of your test, the ones that have a third period, I don't know if you saw the notice that you can come in 15 minutes early to start the test. I'm worried that some of you will work too slow, and I want to make sure that you have enough time. So now I show that it adds up to my overall equation. So then my enthalpy change would be 1/2 delta H1 plus 2 times delta H2 plus -1 times delta H3. And then it's just math. No, there was not a worksheet for that, Farine. Oh, if Chem's 4th tomorrow, awesome. Then you can just stay late. But I thought it was 3rd. But I never know the timetable, so I'm the last person to ask. Okay. Yes, period 2 gets to stay for 15 minutes, and period 4 will get to stay for 15 minutes. You'll both get 15 minutes extra. It's just a question of when you'll get it. Okay, so now that I have my enthalpy change for this reaction, I can calculate a molar enthalpy by taking my enthalpy change and dividing it by the coefficient of any one of them. So take it, and so it's going to work out to so my delta H here is negative 1016 kilojoules, I think. So therefore, I would say my molar enthalpy of reaction would be negative 1016 kilojoules. And if I want to express it per mole of HCl, I divide it by 2. And so then it'd be negative 508 kilojoules per mole HCl. Or I could express it in terms of moles of F2. That's why your unit matters. You use the coefficient from your target equation, and you just pick one of the reactants and you state it as per that. I take the mole coefficient because it's from the balanced equation. Yes, I can use any compound in a target equation. I could usually we express them in terms of amount of reactant because that's our system that we're measuring the amount of, but we can go from there. You could, theoretically, we could also express them in terms of mole of product. No problem. We asked it really. No, I won't ask you really complicated Lewis structures because that's the minor part of the question. Being able to show me everything else is more important. You can express for standard enthalpy of formation questions, you can express it per mole for the product, but usually if it's a multi-step question and you're going to use one of your reactants in the multi-step, I'd try and express it per 1 mole of that. Because that way, if you forget to do your reaction to get out of your balanced equation, then your value will still be numerically correct. You'll just be off by 1 step. You'll have forgotten that. So if it's a multi-step question, I always try to express it as 1 mole of the thing. You need molar enthalpy to go from calorimetry into balanced equation to use the Hess's law. Okay, so I need a molar enthalpy value so that I can do this to get into an enthalpy change for my balanced equation. Likewise, reverse, if I have an enthalpy change for my balanced chemical equation, I have to do this to get out to go and do calorimetry. So this is like your bridge over water, where calorimetry is on one side of the river and your balanced chemical equation is on the other. And this is the bridge that you have to build to get over the water, and you just have to decide which way you're going. A quarter covalent bond is treated as a normal bond. Complicated Lewis structure ones would be fun, but I won't give you hard ones. The mole coefficient that you use is the compound that was your system. So in this case, back to this example, the toluene example, I used the coefficient in front of the toluene because that was my system that I used. And so I have a balanced chemical equation expressed as per mole of toluene. And so therefore, because it's per mole of toluene, I have to use the coefficient in front of toluene so that it cancels that unit. Because if I used the coefficient in front of the oxygen, which isn't even balanced, it wouldn't cancel out. And so I have to use the whatever the system was. Yes, it is a retort stand. I have a retort stand at home. I own my own microscope. I have my own pinhole camera, a catapult, slingshots made out of things. We're like total nerd central here. Except my wife, of course. She's the cool one. Okay, if there's no more questions, I will let you go back to looking at your stuff one last time. Remember, good night's sleep. Number one thing to help you do well on a test. If you don't sleep well tonight, you're going to have foggy brain. And if you have foggy brain, you're going to make stupid mistakes, Nupur. Not saying. So you want to make sure that you get a good night's sleep so that you're paying attention. Okay, one last thing. Wow. Hess's law number 14. Oh my God, Hess's law number 14. The only problem with Hess's law number 14 is you don't have your target equation. Did you heat from heat? Oh, I did the wrong target equation when I showed it before. So this is your target equation. It's for the formation of liquid hydrogen peroxide. I will hopefully be at school tomorrow morning at 8:15, but because I procrastinate like students do, I have to photocopy the test still. I think I probably give you most of the reactions. I have to, finish making the test. Okay, so that's your target equation for question 14. And that will probably help most of you to be able to get there. Okay, I'm waiting, Sahangi. What's your question? Memorize is such a harsh term. You know that. You need to know the specific heat capacities for the different states of water. So that's for liquid, or sorry, for solid. That's for liquid, and that's for gas. And then you need to know your standard enthalpy of fusion and your standard enthalpy of vaporization. Those are the values that you need to know. They're not latent heats because they're not per kilogram or gram. Oh my God, physics is horrible. Those are the values that you need to know. Any values for any other compound, I will give you. If you need the bond energies, I will give them to you. Of course, the melting point and boiling point of water. Listen, that was a Jeopardy question the other day. The person got it wrong because that's in Celsius. And I laughed at them. Don't get it wrong. I'll laugh at you. Don't worry, if you forget the values, I'll always sell them to you for a mark. No, this test is not going to make you cry. It's very fair. It represents what we did. No, you don't need to know Kelvin. Don't we know it? I am always the biggest bully in our class. You know that, Hidessa. From 1 to 10, how do I rank the test? In terms of difficulty of questions, I would say it's a 6, given you know the topic of the hardest question. In terms of you being able to complete it, because many of you are still doing the questions for the first time, I would say then being able to complete it in the time will bump it from a 6 to a 9. But if you've done all of the practice questions and you're familiar with the topics and everything, then it is not a hard test at all. You have to work through the questions methodically, one at a time, following all of the steps that we said for each of the different question types, and you'll be perfectly fine. It's a 9 because you're freaking out. It's a 9 because you haven't practiced enough questions. The test is a 6. Well, you know, I do see everything backwards in my vision on the screen from the camera. So a 9 probably does look like a 6 for me. Okay, I'll be at school tomorrow around 8:15. I'll try and be earlier. Make sure you get a good night's sleep. You would be told if it's a change of state, Anaya. I hope you get more than 3 hours sleep. Anyways, have a good night's sleep, everyone. Make sure that you get some rest. Bye. Yes, combustion is always exothermic.